Problem number 1, which of the following is equivalent to the expression above? Well, we have this first parenthesis, so I'm just going to rewrite the terms. And then here's the key to the question. The second parenthesis has a negative sign out in front. So you have to remember to distribute the negative, or basically to change the signs of every term in this second polynomial. So here a negative negative is going to give you a positive x squared y. A negative times a positive gives you a negative 3xy squared. And then a negative times a negative gives you a positive 3y squared. Now what we're going to do is we're going to combine all the like terms. So here we have a 1 x squared y and another 1 x squared y. So these two terms can be combined to give you a 2x squared y. Here we're going to have a negative 3y squared plus a positive 3y squared. Well, they just cancel. And then we have a positive 5xy squared and a negative 3xy squared gives you a positive 2xy squared. So here your answer was letter C. But remember, for two terms to have like terms, the exact same exponents must be there. So if this second 3xy squared would have been x squared y squared, then these could not have been combined. Problem 4, which of the following is equivalent to the expression shown above? Now you could approach this question in one of two ways. You could try to factor this expression, or what you could do is take your answer choices, simplify them, and see which work. For example, let's say I think answer choice C is correct. Here I'm going to have 9a squared plus 4b squared squared. What that means is to take 9a squared plus 4b squared and multiply it by itself. Because you know, for example, like 5 squared is the same as 5 times 5. So 9a squared plus 4b squared squared means to multiply it by itself. Now, in order to multiply these two together, I'm going to FOIL. And here's where the problem happens. The front, 9a squared times 9a squared is 81a to the fourth. That doesn't match. That doesn't line up. I only need to have a 9a to the fourth. So I know answer choice C is not correct. So here, let's take a look at letter A. 3a squared plus 2b squared squared means to multiply it by itself. And now when I FOIL, the firsts, 3a squared times 3a squared gives you a 9a to the fourth. The outsides, 3a squared times 2b squared is a 6a squared b squared. Insides, 2b squared times 3a squared is a positive 6a squared b squared. And then my lasts, 2b squared times 2b squared gives me a 4b to the fourth. So here's my 9a to the fourth. These two can be combined to give me a 12a squared b squared. And then here is my 4b to the fourth. So it looks like here my answer was letter A. When you have multiple choice math questions, a lot of times you can just take your answer choices, simplify them, plug them in, and see which work. Problem 17. In the equation above, A, B, and C are constants. The SAT loves to give you this term, a constant. A constant just means a number. So A, B, and C just represent numbers. If the equation is true for all values of x, what is the value of b? Well, let's take this left-hand side first and try to simplify it. What I'm going to do is I'm going to distribute twice to get rid of both sets of parentheses. So here I'm going to have 2x times 3x, 6x squared, 2x times 5, 10x, 3 times 3x, or 9x, 3 times 5, or 15. So when I simplify, I have 6x squared. 10x plus 9x is 19x plus 15. So that's what the left-hand side factors into or simplifies into. The right-hand side is ax squared plus bx plus c. So what does that mean? If these terms are equal, that would mean a is equal to 6, b is equal to 19, and c is equal to 15. So since this question said what is the value of b, in this case b is equal to 19. Problem number 12. If the function f has 5 distinct zeros, which of the following could represent the complete graph of f in the xy plane? And here's the definition that you're going to need to answer this question. A zero of a function is just an x-intercept of the function. A zero of a function is just an x-intercept. It's basically a point where the function, where the graph, crosses the x-axis. So if you think about a graph, you have your x-axis, your y-axis. If I draw a parabola, this parabola has 2 zeros, 2 x-intercepts, because the parabola crosses the x-axis at 2 different points. If I draw a line on the graph, this line that I drew has 1 zero, has 1 x-intercept. So this particular question says if a function has 5 distinct zeros, which of the following could be its graph? Look at each of the graphs and look at the x-intercepts. For letter A, it has 1, 2, 3, 4 x-intercepts. Letter B, it has 1, 2, 3, 4 x-intercepts. Letter C has 1, 2, 3, 4, 5, 6. And letter D has 1, 2, 3, 4, 5. So here the answer is D, because the question says the function has 5 distinct zeros, 5 x-intercepts. The graph crosses the x-axis 5 different times. For problem number 29, for a polynomial p of x, the value of p of 3 is equal to -2. Which of the following must be true about p of x? Well, this particular question actually uses something that you're going to be talking about in your senior year math course. But basically what it says is this. If you evaluate a function at a particular value, here we're evaluating the function at 3, p of 3. If you evaluate a function at a particular value and get any number other than 0 as an answer, see how we got -2 as an answer, then the answer, this -2, is the remainder. So the -2 is going to be the remainder when the function is divided by basically this number here. So if you have a polynomial and you evaluate p of 3, as long as you don't get a 0, if you get a 0, it actually is like the last question that we did, talked about a 0 of a function. Well, if you evaluate p of 3 and get a 0, then your graph is going to cross the x-axis at 3 because it's a 0. But here, since p of 3 is equal to -2, what's going to happen is the answer is going to be D. -2 is going to be the remainder if the polynomial p of x is divided by x minus what's in parentheses, x minus 3. So if I take this mysterious p of x function, which they don't even give you, but they don't really need to give you, if I take that function and divide it by x minus, in this case 3, because I'm evaluating p of 3, then the answer that you get, -2, is the remainder. And this is going to be something that you're going to be learning very, very early in your pre-calculus math course next year. For number 10, which of the following equations has a graph in the xy plane for which y is always greater than or equal to -1? Well, this is one of the few questions on the SATs where actually graphing the equations can really answer the question. So on your graphing calculator, the way you graph an equation is you press the y equals button. The y equals button is in the upper left-hand corner of the calculator. When you press that button, you'll see up to 10 different places that you can enter your equations in and graph. The button that you use to type in x, because all these equations have x, is this button that's next to alpha, this x, t, theta, n button. So what you're going to do is you're basically going to type in these equations exactly as you see them. And you see how I showed you how I graphed all 4 of these equations. You type in these equations exactly as you see them using this button next to the alpha as your x button. Problem number 1 deals with absolute value. The way you get to absolute value on your calculator is you press the math button, which is directly underneath alpha, and then you use the right arrow button over ones to number, and then absolute value is option 1. So you're going to have to play around and get used to the graphing. You're going to be graphing in your junior year math class, so if you haven't seen so already, your junior math teacher will be showing you how to graph basic equations. But what you're going to be doing is you're going to be graphing all 4 of these equations and then looking to see which of them has y always greater than or equal to -1. So when you enter your equation, so for example for the first one, absolute value of x, then -2, the way you graph is you type your equation in as you see it, and then you press zoom, and then the number 6 for zoom standard. What that does is it gives you what we call in math a standard view of the graph, going from -10 to +10 on the x-axis, and going from -10 to +10 on the y-axis. That's called the standard view. Now we're looking for the graph, the equation, where y is always greater than -1. So let's look at all these equations so I can show you what that means. Here's the first graph, and they want y is always greater than -1. Well, here is -1 on the y-axis. It's 1 unit down from the origin. So here is the line y is equal to -1. And if you notice, this particular equation goes underneath that y is equal to 1 in this middle section. So that's why the answer to the first one, this absolute value of x minus 2, is not the answer, because there's a section where the graph goes underneath y is equal to -1. Look at this second graph, x squared minus 2. If you look at that one, again, here's the line y is equal to, here's -1 on the y-axis, so here's the line y is equal to -1. And again, notice this graph goes underneath, meaning it's less than -1. So letter B is not going to be the answer. Letter D has a whole bunch of sections of the graph. Here's y is equal to -1. All of this is all underneath, so all of that is less than -1. That's not the answer. The only equation that stays above that y is equal to -1 line, because again, here's my y is equal to -1, the only equation that stays completely above it is option C. So that's why your answer is letter C. This is one of the few questions on the SATs where having the ability to graph on a graphing calculator pays off. Problem 33, if you have this expression, and if it's rewritten in the form ax squared plus bx plus c, a, b, and c are constants, so again, there's that math word, a constant, it just means a number. What is the value of b? So very similar to the earlier question that we did. So what I'm going to do is I'm going to simplify this expression. The first equation, the first term that is going to stay as is. So -3x squared, so the first polynomial I'm just copying over. negative 3x squared plus 5x minus 2. Now I'm going to distribute the negative 2 to all three terms. So negative 2 times x squared is negative 2x squared. Negative 2 times negative 2x is a positive 4x. And then negative 2 times negative 1 is positive 2. Now I'm going to put together the like terms. Negative 3x squared and a negative 2x squared gives you a negative 5x squared. Then I have 5x plus 4x, so that gives me a 9x. And then again, the negative 2 and the positive 2 cancel. So this particular question is saying if you rewrite this in the form ax squared plus bx plus c, that would mean a is equal to negative 5, b would be equal to 9, and c would be 0 because there's no term without an x. So here the question says what is the value of b? So this is a grid question. You would bubble in b is equal to 9. Problem number 25. For these two polynomials, which of the following of these answer choices is divisible by 2x plus 3? So if an expression is divisible by 2x plus 3, that means it's going to have as a factor 2x plus 3. So I'm going to try to simplify these, and then after I get done simplifying, see which of them has a factor of 2x plus 3. Now, some questions are more challenging than others, and this one here I think would fit into the more challenging category. Look at f of x. Before I try to simplify any of these answer choices, if I have f of x, this particular function has a greatest common factor. 2 goes into all the numbers, and here you have an x, an x, and an x. 2x is going to be the greatest common factor. So if I factor out a 2x, that's going to leave me with 2x times x squared is 2x to the third. 2x times 3x is going to give me 6x squared. And then 2x plus 2 is going to give me 4x. So this function f of x up here is the same as 2x times parentheses x squared plus 3x plus 2. So when I simplify each of these and when it says f of x, I'm not going to throw in this version of f of x, but rather this form of f of x. Now take a look. G of x has part of f of x. G of x is just the parenthesis portion of f of x. So basically what I'm going to do is this. F of x is equal to 2x times x squared plus 3x plus 2. That's what f of x is equal to. But that would be the same as 2x times this g of x. So basically function f is just going to be 2x times function g. And that's the trick to the question. Because when you try to do, for example, answer choice B, when you try to simplify it, watch what happens. F of x plus 3 times g of x. This is answer choice B. Now when I simplify and substitute this in, this is going to give me, well, f of x, which is 2x times g of x, plus 3 times g of x. Now I know g of x is equal to this x squared plus 3x plus 2, but you see how this and this have g of x as a factor. So whatever this answer choice B simplifies into, it's going to be g of x, because it's a common factor, times 2x plus 3. So if I would actually do the math and simplify answer choice B, it's going to have as a factor 2x plus 3. And that's why the answer is answer choice B. See, the key to that question was understanding that this first function had a greatest common factor of 2x, and the parenthesis part happened to be the same as g of x. Certain questions on the SAT are very straightforward. Others, like this one, are kind of testing your ability to see something that's very mathematically involved.